standard hydrogen electrode SHE, or it is also called a normal hydrogen electrode. So, it is NHE. What is this standard hydrogen electrode or normal hydrogen electrode? When it comes to construction, it is the same way as we already discussed about the hydrogen electrode. The hydrogen gas is taken in a test tube, in a glass tube. A platinum wire is inserted into it. Here it is dipped in. Here hydrogen gas is filled into this. Hydrogen gas is filled at a pressure of 1 atmosphere. Pressure is 1 atmosphere. Pressure of hydrogen gas is 1 atmosphere. Here you have a solution of H plus. Concentration of H plus is 1 molar. And here you have a hydrogen gas. And this is of course platinum wire. So, it is just nothing but the construction is same as in the hydrogen electrode as what we discussed. Only thing is there in a normal, I mean in general it can be any pressure, but when you are talking about a standard hydrogen electrode, the pressure maintained in the tube should be exactly 1 atmosphere and the concentration of H plus ions in the solution should be exactly 1 molar and the temperature should be maintained only at 298 Kelvin. At this case, the cell reaction, if you represent the reduction as the representation is like this: H2 gas at a pressure 1 atmosphere, platinum. This is the representation for standard hydrogen electrode. So, the reaction is that this is the reduction, and for this E naught value is E naught H plus by H2 is equal to 0. This is the standard reduction potential of, this is the 0 value is taken. Standard reduction potential value of hydrogen electrode is taken as 0. Taking this, now this is connected to suppose a zinc electrode, where you write the cell notation as this. Now, this value is 0. So, whatever may be the E cell what you get, which is E Zn to E naught R, that is E H plus by H2 minus E naught cell is equal to E naught H plus by H2 minus E naught Zn2 plus by Zn. This value is 0. So, whatever the measure you, that is E naught Zn2 plus by Zn, which is measured as minus 0.77 volts. So, from this whatever the E naught value we are getting, that is nothing but the E naught value for the zinc electrode. So, using this reference electrode, the values of other electrodes have been determined. So, this is called standard hydrogen electrode, which is a primary reference electrode. Because we have certain other reference electrodes, that is secondary reference electrodes. Then what is the difference between primary reference and secondary reference? Primary reference is always hydrogen electrode, but always everywhere in every laboratory it is not possible to construct standard hydrogen electrode. It is not always possible to maintain standard hydrogen electrode. So, another reference electrode like calomel electrode, quinhydron electrode, glass electrode, we have different other electrodes. We take any of this as the reference and those values are first determined using this hydrogen. Then hydrogen is not necessary to be maintained, those can be maintained and those values are exactly known and they are used as reference electrodes to measure the EMF of any third cell. So, first using hydrogen electrode, the EMF of quinhydron or EMF of calomel are determined, they are used to determine the EMF of other cells. So, they are secondary reference electrodes. This is first primary reference electrode. Regarding secondary reference electrodes, next we are going to discuss, but before that let me conclude this, that this is the standard hydrogen electrode. Using this we can determine the E naught value of anything. and then this with change in this value, of course, EMF will change, but this is always for other cells you can have any other condition, but when you are using it as a reference electrode, these conditions are always, these are the conditions at which EMF, if it is measured, then only it is called standard reduction potential. Standard reduction potential means the potential is measured under the standard conditions.